All right, welcome to module 2.2 for Inside the Case of a Computer. This is still under basic concepts of hardware for grade 10 information technology, and let's just get to it. So, just a quick recap from the last section, module 2.1, basic concepts of computing. Computers consist of the processor or the CPU, memory or RAM, storage in terms of hard drives, input devices such as mice and keyboards, and output devices such as monitors and printers. And today we're going to go into a bit more detail about each of these topics. So let's get to that. So here we just have a quick overview, just like a graphical layout of how all of these components fit together. And you can see we have the input coming straight into the processor, where it can be moved either to main memory or to back-end storage, such as hard disks or USB pens or CDs or DVDs, whereas main memory deals with things like RAM and ROM, which we talk about next year. And then, of course, output would deal with monitors, printers, speakers, data projection, etc. So inside the case of a computer, let's talk about that now. What's actually going on inside of this computer case? So for now, when I'm talking about computers and examples, I'm going to mostly be referring to desktop computers. But what's interesting is that the same general principles actually apply to all computing devices. So it's the same story with your laptop, same story with your phone. If it's a computer, it's got all of these components. So computers need to be housed to protect the hardware, of course. It needs somewhere for those fragile electronic components to be kept safe. So those circuit boards that I'm talking about, they're fragile. They break easily if they're mishandled or mistreated. So this is where we have computer cases come in to solve this problem. So desktop PCs come with a wide variety of different case options that, meet a whole bunch of different aesthetic choices. Good cases look nice and have lots of fans for cooling to keep the computer nice and cool. We'll talk about that in a second. But really, any case will do, really. Whatever you can get will be good. Like, literally anything you can build into. If you can dream it, you can build it. Computers are often built into all kinds of modified cases. You can see here we've got one built into a microwave even. That's perfectly okay. And one built into a literal trash can. So here's just a quick layout of what it looks like inside of the case of the computer. So you can see over here, we've got a lot of space over here. Let me pull up my laser pointer. Actually, you can see over here we've got a lot of space over here under the motherboard, or in this the largest section of the case is dedicated to the motherboard, which is this central circuit board, which all of the components I've been talking about connect to. We'll talk about that a bit later. We've also got space for the power supply, which supplies power to the motherboard, as well as for all of your storage drives and also your CD drives, which go up here. And you can see that we've got space for air intake to come in and then exit over here through the top past the motherboard. So here it is with everything filled out. We've got some fans up here. The first things I see are the fans. We've also got the motherboard over here. It looks like some kind of expansion cards connected over here as well. Here's that power supply I was talking about, 520 watt. Some storage devices over here, and it looks like they've got a CD tray plugged in as well over here. So yeah, let's move on. So now let's talk about this motherboard component that I've been talking about. So these are some examples of some motherboards. These are pretty low level ones, but you get much beefier ones, and you also get much less performance orientated motherboards. So MOBO for short. The motherboard is a large piece of circuitry that features different slots and connectors for other bits of circuitry and devices to connect into. So the motherboard is what allows all the component parts of the computer to communicate with each other. It's the backbone of the entire computing device. So computers are built so that the motherboard is fitted with all the I/O ports accessible from the outside of the case. I'll show you what that looks like again just now, but you can kind of see it up here. These are all of the I/O ports that they're accessible when you look at. In fact, if you just look at the back of a computer, all of the I/O ports that you see are directly part of the motherboard. So we'll take a look at that now. So here you can see these are the connectors that you'll see at the back of a computer, and they're literally connected directly to the motherboard. It is the motherboard that you're connecting those peripherals into. And I'm not going to go through all of these components, but if you want to pause here and take a look, you'll see we've got some PCI slots here for expansion cards, your DIMM slots here for your RAM. Around here will be your SATA connectors for your hard drives and for your disk drives. Over here is where you plug in your power. These we don't really use anymore. Here's your CPU socket, and also the the mount for the CPU fan and the heatsink. There's a lot going on here, and we're going to get into this in great detail in the coming years. So that's the motherboard. So now we're going to talk about this section over here, which we did briefly just speak about, the ZIF socket, which is where we put our CPU. We'll also talk about the DIMM slots, we'll talk about the SATA ports, we'll talk about the I/O peripherals, and we'll also talk about these PCI slots, these expansion slots as they've spoken about. But for now, let's start with the main attraction, the CPU, the thing that's actually doing all the processing in the computer. So the CPU and the cooling fan, the CPU stands for Central Processing Unit, hence it's the central unit that's doing all the processing of instructions in the computer. It's the part of the computer that is responsible for, as I've just said, processing instructions, nice and easy. They're extremely expensive and very fragile due to all of the rare earth minerals that are used, minerals that are used to construct the CPU on the low level. It's a very complex, very highly complicated piece of circuitry with a lot going on. It requires a lot of engineering to get just right. The CPU, as I've already said, fits inside the ZIF socket in the motherboard, which stands for Zero Insertion Force. And the reason why that is because, as you can see here, you don't want to put too much force on the motherboard, because if your motherboard has pins, those pins can bend really easily and then completely destroy your motherboard. So now let's talk about the cooling fans. So CPUs get super hot while they're operating, like so hot you could literally fry a steak on it. I've seen videos of somebody frying a small piece of meat on a CPU. It's crazy. CPUs that get too hot will cause catastrophic damage, because that damage is going to happen to all of the component parts around the CPU. So the motherboard, all of the solder connections for all of the electronic components around the motherboard are going to loosen. They're going to come undone. The motherboard's going to stop working. And in a worst case scenario, you can actually melt the motherboard and seriously damage the thing. So we've got to be careful about this. We need a cooling system, which is typically in most computers one of these, a fan mounted to a heatsink. So you can see over here it connects into the motherboard, and then you get distinctly better ones as well. Some heatsinks just do better jobs than others. So it's all about how much you want to spend. Okay, let me come back to the slide. So what's interesting is that these CPUs, or these heatsinks, you don't really need to know this for the tests and exams, but the heatsink is designed out of a special kind of heat conductive metal, and it's been designed in such a way to create the most surface area possible for the most cooling to happen. So I mean, if you have a larger surface area to put air onto, then you have a better chance of being able to cool a larger portion of the heatsink, and therefore have a greater efficiency with your cooling. You don't really need to know. It's just interesting that that's how it works. It's just highly heat conductive metal that's being cooled over a large surface area. So here's a quick diagram of what's going on with the heating in your computer, and you can kind of see or the cooling in your computer, that as I showed you earlier, the air is coming in through the front, is cooling down what would be over here your hard drives, and then goes over all of your other components, because your hard drive arguably is the thing that needs to be cooled the most. Your CPU will get cooled enough, but your hard drives need to stay the coolest without a doubt, because that's your really important data there. And then it gets blown out through the back through these exhaust ports, and this is why you sometimes see fans at the top over here and fans on the back over here, and also fans over here in the front, because it's sucking air through the computer in order to provide a better cooling experience. So always make sure that your fans on the top and the back are pointed outwards, and the one on the front is always pointed inwards. So you also get something called liquid cooling. Now, liquid cooling uses supercooled water through these pumps and these coolers to pump through like special things. I don't really know what to call them over here, like these plates that mount directly to your components to keep them cool. And this is like really specialized equipment. Like you're really going to spend a lot of money to get a system water cooled. And The problem with a water-cooled system is that if you want to move your computer, you have to drain the cooling system to be able to move it, and then you have to refill it again. Otherwise, if something happens in transit of your computer, it could be catastrophic. You know, water leaks everywhere, damages the equipment. So you really got to be careful of that. What's also interesting though is that I've seen a couple of videos where people have done straight up comparisons of fans versus water cooling and have found that the fans in some cases actually operate better than water cooling systems. So it really depends on the application. You really want to do some research on this before you spend a lot of money to get a water cooling system. But I should mention, this is not theory. This is not assessed at the level that I'm going into it. You just got to know that you can also cool your computer using water cooling in the same way that you can use fans and heat sinks. But it's also much more expensive and has a lot of issues that come with it. So the speed of the CPU is measured in gigahertz. Just important to note, you'll always, whenever you're measuring a CPU, it will say something along the lines of 2.4 gigahertz. This is a measurement of how many instructions it can process per second. But what are cores? I think we... do I talk about that now? No. Okay. So what are cores in a CPU? So cores in a CPU, you might hear somebody talking about, oh, it's got this many cores. It's maybe this many gigahertz, but it's got this many cores. So what is the cores that are being talked about? So the cores deal with how many processors are actually inside of your central processing unit. So what I mean by that is, if you think of a processor as something that interprets and executes one single instruction, then having a multi-core CPU means that you can process more than one instruction at a time. So it's the difference between trying to process 5 instructions through one core versus trying to process one instruction through 5 cores, or 5 different instructions through 5 cores. The one's going to be 5 times faster than the other. So that's what we mean by cores. So you want to have as many cores as possible. I've seen some CPUs that have like 8 cores, but most of them tend to max out at about 4 to 6 cores. And I think most of your phones either have 4 or 6 core CPUs. Now, if you ever want to look that up, just go search up, just see if you can find what CPU you have, and then just go search it online. You'll see exactly all the specs about it. So everything in a computer is designed to get data instructions to the CPU for processing. I think, I wish I could show you a picture of a motherboard now. I'll show you that when we get to the next slide, or a couple of slides from now. But really, it's hardwired on that motherboard. There's no magic happening. It's an electronic circuit. It's a very complicated electronic circuit, but it's still an electronic circuit that is wired in a specific way. And as I showed you earlier in I think the first or second slide, when I showed you that diagram of the layout of a computer, the input goes directly into the CPU. There's a few more components that it goes through that we're not going to talk about now, because that's like, third year computer science architecture stuff. But for the most part, what you need to know is that it is coming direct into the CPU to be processed. And this processed information can then be stored, transferred, communicated, or outputted in some meaningful format to the user via some kind of output device. So, you can't really see it here, but if you look very carefully, all of these lines that you see here that are doing this, these are actually the wires of an electronic circuit. These are the traces on a circuit board that are carrying this information, this presence or absence of electronic signal that I'm talking about between, the CPU, the memory, the input. It's all coming through these wires and is going in a very specific way. There's no magic happening here. So that's the CPU. Now, let's talk about these DIMM slots, or random access memory, RAM. We did speak about it last time. Let's go into a little bit more detail with this RAM and where they connect. And I guess we'll do that in the next one. I'll see you then.